Hello, hello. Welcome one, welcome all for another installment of the LeetCode Reddit LeetCode streaming. Even though I said LeetCode twice, that's fine. LeetCode Reddit LeetCode streaming. We're here today for the seventh installment where we're going to continue where we left off. So if you've been following along, if you've been watching all the previous streams that I've done, and you've been able to do all the questions, you should be around 35 questions right now. So that's pretty cool. If you think about someone that's never done LeetCode before, and now they're doing LeetCode for the first time, they're trying to get some questions under their belt. Now, pretty much not even within a week, because I haven't even done this for a week. It'll be Saturday that I've done it for a week. Now you're sitting at 35 questions. So that's some pretty good progress. So I just want to give some quick channel updates real quick. So for some of you that this is not your first time on the stream, you do know that I upload these to my YouTube channel. And let me just explain to you the intent of the YouTube channel. So I make all my streams on Reddit, on RPAN, and then I upload video to my YouTube channel. And this way, you can watch the video at your own pace. You can do the questions and then watch the video afterwards, or you can do the questions while watching the video. Either way, you're either going to feel like you're being able to code along with someone. You'll be able to hear me struggle and make mistakes and hopefully come up with like an optimized algorithm by the end of it all. So I think it's a pretty great way to go about it. Good news is I have 12 subscribers now, so I know that's really not a lot in the grand scheme of things, but I'm very happy and I'm very proud about that. So hopefully people watching, if you want to tag along, if you want to join in the fun, hopefully you'll subscribe. I'll put my channel link here on the live stream. That way, anyone that wants to visit it can. And one new thing that I added, so one thing that I had added before was the ability to, like, you can see the questions that we worked on, but I thought to make it a little bit easier, it would also be beneficial to have chapters. So now not only do I present the link of the actual question, now you can actually click on one of the chapters. So if I, for example, I start here in the first video and I say, oh, I want to see running sum of 1D array, I can click on that and it'll take me right to that question, and then you can just work on it like that. So that's pretty much all the introduction I had. I'll probably go for about an hour like I usually do. So without further ado, let's see what the next question has in store for us. And I hope that some of you all can tag along with me. So count of matches in a tournament. Okay, so you're given an integer n and the number of teams in a tournament that has strange rules. If the current number of teams is even, each team gets paired with another team. A total of n divided by 2 matches are played, and n divided by 2 teams advance to the next round. If the current number of teams is odd, one team randomly advances in the tournament, and the rest gets paired. A total of n minus 1 divided by 2 matches are played, and n minus 1 divided by 2 plus 1 teams advance to the next round. Return the number of matches played in a tournament until a winner is decided. Now, unfortunately, I know there's a very dumb trick to this that I think I remember, but let's try and go ahead and simulate it because I think that's really what we want to do, right? Match is won and one team has declared their winner. Let's see, until a winner is decided. So are we always left with matches won, matches, okay? And do we have the number of teams tournament that has strange rules? Current each team gets paired with another team. A total of n divided by 2 matches are played. Okay, so let's see this. First round, teams is 7. One team randomly generates in the tournament and the rest gets paired. A total of n minus 1 matches are played and n minus 1. So I feel like we're going to do something. Let me see. 2, third round, output is 6. 3, 2, 1, and that's how many matches. So we want to do, I guess I want to do this while the amount of matches is not 1, and then I'll stop when it gets to 1, and then from there maybe we can do some math to figure out the rest. Something like this. So let's see. Let's first calculate the starting match. So starting, let matches. Actually, maybe I want to calculate calculate matches. Matches takes n, which is teams, number of teams. And what is this going to return? Teams, if teams modulo 2 equals 0, this will cover our even case, else we're nowhere with odd. If the current number of teams is even, each team gets paired with another team. A total of n divided by 2 matches are played, and n divided by 2 teams advance to the next round. So here we have return math.floor of teams divided by 2. If it's even, if it's odd, and the rest gets paired, a total of n minus 1 matches are played. Calculate matches n minus 1 divided by 2. So let's do return. We'll do the parentheses first, right? So I want to do, yeah, let's do math.floor of teams minus 1, and then we'll do divided by 2. This gives me matches. How many teams advance? And 4 teams advance, 2 teams advance, and 1 teams advance. How many matches did we have for each one? Okay, 1 team advances, 1 team advances, 7, 3, 2, 1. Okay, so can we do, let's see, do something while calculate matches of n is not equal to 1. But maybe I should also say, let's say let current teams equals n. So calculate matches, this is going to give me the matches, 7 teams, and then every single time we can get the amount of matches that we have. 7 teams, but then we also have this weird team thing, right? This team thing is also like its own. So let's say calculate matches, and let's say calculate teams. And divided by 2 matches are played. Calculate teams. We'll also create a function for this. Okay, so same logic here. If teams divided by 2, a total of n divided by 2 matches are played. Okay. And then a total of matches are played, and n minus 1 divided by 2 plus 1 advance. Okay. So we start off with 7 teams, 3 matches, and 4, 7 teams, matches 3. This is like a weird way to start here. Teams 2, teams 2. Maybe I might even instead of saying teams, 4 teams advance, that's 4. And 2 teams advance, that's 2. So maybe as long as this is greater than 1, maybe this is going to be a better thing. While current teams is greater than 1, current teams is n, teams is 14, matches equals 7. So let's say let current matches equals 0. Current matches equals calculate matches of current teams. Teams is 14. Matches will be 7. And 7 teams advance. But for current teams, calculate matches and then current teams. Current teams equals calculate teams. And do we just take the current teams? But this is going to have to. Perhaps I think I maybe like started just code. This is one of those situations where maybe I started coding instead of like thinking about it a little more before. Team 7, 4, 2, matches 3, 2, 1, 4, 2, 1, 7, 3, 2, 1, 13. Okay, we're gonna go back to the drawing board here. Oh, you can get rid of the if else. Oh, you mean just like, do you mean something like this? Like instead of having instead just do something like this just to clean it up? It's funny because I was reading about this sort of like coding style recently, where like if and else doesn't look too nice. But yeah, if it's just this, we return this, else just return that. Is that sort of what you meant? Thanks for the suggestion, by the way. Love seeing comments on the stream. That's really nice. So what is it that we want to do, right? Return the number of matches played in the tournament until a winner is decided. So we want to do this until there's one match left. So something, do something until one match is left. We start off with the amount of teams. I meant ternary if there were no other cases. Oh, sure. We could do that, right? Yeah, I guess we can really like condense this. Yeah, I'll probably do that when I get back to this. That's a good point. I'm just trying to write this out so because I do this a lot and I talk about it a lot. The funny thing, like sometimes it works out well where I really plan something out, and other times I just dive right into the code, and then this happens where now I'm just like confused. Okay, so do something until one match is left if the current number of teams is even. So it looks like the driving thing is even, right? We have 7 teams, which gives us 3 matches and 4 teams advance. Okay, so we have some amount of teams. We calculate matches, recalculate teams. So here, let's see, right? We have some amount of teams, calculate matches, recalculate teams. Okay, cool. Now we have 4, gives us 2 matches. Okay, and we have 2, it gives us 1 match. Okay, but then this is 1. So yeah, I think this is already like I'm seeing an easy way of doing this here. Matches, we can just say let, what if matches is 0, and then while, so teams, this is going to be matches and 4 teams advance. So we have the starting amount of teams, and this gives us a match. Teams match. Teams match. And this is number of matches. I also want to say, yeah, let current, yeah, teams match, teams. Yeah, let current teams equals n, and do while current teams is greater than 1. So what are we doing here? We have our teams, we calculate matches, matches plus or equals. Now maybe here we can use our match, right? Calculate matches. And I'm going to suggest what you decided. So yeah, we can even make this vary because this fat arrow here, teams 2, we can just return this, else math.floor, we'll do that, right? And then here, we can actually just remove all this, just keep it like this. So teams match, while current teams equals 1. So current teams is 7, matches plus or equal, calculate matches, give it a teams, and then how many teams advance. We have calculate teams up here. Let's do the same thing. Let's come over here. Let's do this. And then we'll do math.floor. We will remove all this stuff and also this. And then here we can say uh, current teams equals calculate teams. So let's see. So do while current teams is greater than 1, matches will be plus or equals 3, and then we recalculate teams. Now it's 4. Matches plus or equals current teams. All right, so this should be current teams, the things that ends. Like current teams equals calculate current teams. And then we get to matches plus or equals this. Current teams is this. And then it's not greater than 1, so we should end up with matches there at the end. So sort of similar to what I started with. Return matches. We can remove this. Let's see what this gives us. 6 and 6. 6 and 13. Okay, cool. So that gave us the right answer. Yeah, I got a little carried away there in the beginning. I felt like I definitely made it off on the right foot. But again, just taking a second to plan my algorithm out really did save me there. So I like this question a lot because I used, I'm happy with like the functions I used here. I thought they were like pretty descriptive. Definitely something to keep in mind when you're working with, or rather if you're doing an interview, if you can try to find a way to abstract logic into different functions like this, it'll help a lot. And the do while helped out really nicely here because it's exactly what we want to do. We want to do this thing while current teams is greater than 1. It worked out very nicely here, so I'm very happy about that. Now, I think the clever trick here, let me submit this again. 52.03. If we think about the time and space complexity, are we, I mean, I don't think it's fair to say like, is this log n? Are we like halving the problem space every time? I'm very curious to know if this is like a log n solution or if it's just linear. Space complexity looks to be constant here, which is nice. Now, I'm about to maybe blow your mind right here. I think the answer is just return n plus 1. Well, we know that's going to work for these two, but let's see. Oh, 8 and 15. Okay, no. Oh, no, I'm sorry. I think it's n minus 1. 613, 613. Yeah, I forgot how I think I probably just like read the solution somewhere a long time ago. I mean, I remember seeing this question years ago. Obviously, this is extremely efficient, and if we want to be very JavaScripty, we can actually go as far to just say n here, remove this, n minus 1, get rid of this guy down here, comment this out. Doesn't look nice. Well, I mean, actually it looks great, but it's not very descriptive. Doesn't really mean anything to me. Okay, and somehow that performed even worse. I'm gonna leave it with the one I came up with because although the other one's very clever, I think this one at least, hopefully you can flex some of your coding. But let's read the discussion and see. Just return m minus 1. Okay, O of 1. Does he say why? N teams, one match, one lose, one eliminated. The champion never loses. N minus 1, other team lose. So need n minus 1 match. When I see this, I have to delete my solution. Maybe I work smarter, not harder. Backtracking, C++, O log of n. Nice. So yeah, a little bit similar to what I did in a functional one-liner. So that's good. It's a log n solution because we're essentially halving the problem space every single time. So that's pretty nice. Sweet. So let's move on to our next one. I don't have premium anymore, so I can't do this one, which I really, really do like. Let's see, of maximum nesting depth of the parentheses. The string is a valid parentheses string if it meets one of the following. It is an empty string or a single character not equal to this or this. It can be written AB, where A and B are VPSs, or it can be written as, okay. Yeah, so this question has a lot of text. I just scroll down so I can see the input and output. Helps me a lot. Now, this is a very important thing right here. It is guaranteed that the parentheses expression S is a VPS. Great thing to ask your interviewer. Can I assume that every sort of token will be a VPS? If you think about a question like balance parentheses, we know that it's like some of them could be valid, others can be invalid. You might need to terminate early, but in this case, this is valid for every single sort of token. So when I look at this, what I think of is I really just need to count. I mean, there's two ways I can think about this. One of them is using a stack. A stack is generally helpful for parsing strings. Or can I just use a counter and say like, okay, I see an open parentheses, so that's one, and I see two here, and then I see uh, one because that's closing. Then I see two, three, then two, one, zero, right? So anytime I see a one, I add, and then anytime I see a closing, what should we do here? Because actually, or even since I know it's a valid VPS, I just take the max anytime I see an opening, I think. Maybe not though, because then that would mean this is four. So this is one, then we have another one, we close. Okay, so we close. So then we get to this one. So let's see. We're like at one. What's the max? Zero or one? One. We go to zero. We go to one. What's the max? One or one? It's just one. Now we get to two. Two is the new max. One, zero. One, two, three. Okay, so I think anytime I see an open parentheses, that can be my counter. So let's say open parenthesis equals zero, and let's say max equals zero, and I'm just a sucker for alphabetizing variable names. Don't hate me. For const C of S, where C is the character, if C equals an open parentheses, let's see, do I want to add first, then take the max? That's the new max, right? Perhaps we can do open parenthesis plus plus max equals math dot max of max, or open parentheses, else open parentheses minus minus. And then we return max. Let's see what this gives us. Ooh, 1, 1, 3, interesting. So I'm obviously missing something probably simple here. Let's go through this again. So if C is open, right, open parentheses plus plus, that's 1. Math out max of 0 or 1, that's 1. Come here, open parentheses, 2. Max equals math dot max of max or open parentheses. Are these not const C of S? And I got, for this one, I got 1. Should we always have, see, I really did think, why is that not, okay, let's go through it again. It's actually just, well, let's use this here. Okay, so we're at C. This equals open parenthesis. So this is 1. Max equals math dot max of max, which is 0, or open parentheses, which is 1. Okay, so max should equal 1. When we get to here, oh, I wonder, else if C, I need to be explicit about my check, because I don't want to check just any character. It needs to be a closing parentheses for me to be able to close it. Or not close it, for me to be able to decrease that number. So 3 and 3 passes both the test cases there. Again, 3, 3. Let's see what this gives us. Okay, sweet. So I'm very curious, like, we can probably do this whole thing in a reduce, but really the logic, return if it's open. Let's see. open, return act plus 1, math.max. Yeah, I think reduce might make it a little bit hard to read, and the logic's going to be the same, so I'm happy with this. This here will be linear time and constant space complexity because we have to traverse the entire input string, and the amount of extra storage space that we need does not change with the length of the input string. So let's run this again. Pretty happy with this. Discussions, parentheses, problem, foundation. Yeah, so very, very similar to what we did here. And he even combined both of these together in one. The depth equals the maximum open parentheses. Sweet. Okay, let's get to the next one. Convert binary number in a linked list to an integer. The most significant bit is at the head of the list. 101 in base 2 is base 10, so most significant, right? So this would be, okay, this should be a fun question. So 101, right? So if we think back to, let's say we have 2 to the power of 2, 2 to the power of 1, and then 2 to the power of 0. Some of them are going to be on, others are going to be off. And if we add all these together, like 2 times 2 is 4, times 1 is 4, 2 times 2 to the power of 1 is 2 times 0 is 0, plus 2 to the power of 0 is 1 times 1 is 1. So 4 plus 0 plus 1, that gives us that. I think what we can do here, I feel like solving this recursively. Can we do this recursively? I think we could. Then every single time, because I feel like I can just go all the way to the end. Maybe I keep track of, might be able to do it iteratively also, but there's nothing, I mean, we can maybe like, it's a couple different things we can do. We can like reverse the list and then just, we can start at 0 and then just iterate over it and do this formula. That's like one thing we can do. We can also just start, let's see, that's like, well, yeah, that's one way of doing it. If I do it recursively, I might have this sort of like my multiplier, I guess, or my exponent, the power, be something that increases as I go along. So let me show you what I mean here. So let me comment this out. I might say something like, it's guaranteed that we actually get the linked list is not empty. Okay, so what if we did let power equals 0, and we define a new function here called something like traverse. This will take the head, and then let's say let sum equals 0. Here we can call traverse head and then return sum. So what do we want to do? Like start at head here, then we go here, and then we go here. So at the moment that the current head.next, like my base case could be if head.next equals null. We want to, I don't think, we don't really need to return anything, but here we can do sum plus or equals math.pow of 2 to power times head.val and then return. So sum of, so like 0 will be equal to math.pow of 2 to the power, which is 0, times head.val, which is 1, and we'll just add the 1. And then down here, now we'll be at 0. We've already increased, oh, we need to make sure that after this we increase the power. Then we can just sum plus or equals math.pow, power times head val. Do the same thing here, power plus plus. I think there's a better way that I can condense this, but let's see what this gives us. 1 in 5. power plus plus. Oh, of course. Inside of here, we need to call head.next. 5 and 5, and for 0, 5 and 0. Let's see what this gives us. 30.54, 61.93. I think what I can do though is instead of checking this, maybe just like uh, if not head return traverse head down next, and then we should be at the same spot. 5 0, 93.89. Now, if I'm like, I think there's like a really nice way of doing this though, just by doing it iteratively. Let's think about this. 5 0 1. If we go 0 1 0 1, like if I were to do it iteratively, how would I be able to get that this is like it's going to be some bit manipulation for sure. 1 0 1. We already had our pattern, right? We don't know what hmm, because I don't know the length of head of time, how would I be able to know like this significant bit, what power does it have? I would need to know that it's a 2 if I just want to do this like in one pass. Because this might be, I mean, this works, but maybe I'm sure there's a very clever, nice way of doing this. 1 0 1. 2 to the power of 2. Like, what options do I have? So this is one of those things that's like, it'd be nice to know common bit manipulation techniques because I don't really know what would be helpful here. Will like any sort of shifting be helpful? What if I like shift over the thing to the right? Or like, if I shift to 1, if I shift to 1, is that going to do anything? Like, what if I use the current thing I'm on to do a shift right? So I push 1 over, I have 1 1 0. That's just going to give me what, 6? That's not very helpful. What if I do it the other way, where I get, if I push a 1, I'll have 0 1 1, 0 1 1. Okay, that's 3. If I go to the next one, now I push another 1. Well, that's 7. I mean, but no, I push a 0. Yeah, that's 6. 1 1 0. That's not really going to do anything for me. And then if I push a 1 at the end, that's already greater than my current value. I'd like to come back to this one. I have this list here called Reddit Stream Revisit. I plan probably like on the weekends, maybe like on a Saturday, I'll do a sort of like a weekly roundup where we visit, talk about some of the things we've accomplished for that week and maybe revisit some of these other questions. Maybe not even to spend too much time on them, but anyway, this has an official solution, so let's see. Guaranteed to be done. 2 seconds. The problem is to convert. Solved in 2 ways. To use classical arithmetic is much more straightforward, and to use bitwise operators is faster. Okay, the current value is head.next.val. Update the result by shifting it by 1 to the left and adding the current value. We'll hold that next, not equal to null. Num equals num times 2 plus head dot next dot val. Bit manipulation. Current value is update the result by shifting it 1 to the left, finding the current value. So are we always doing 1? Oh, this is crazy. Oh, but I guess we're, yeah, num shifted by 1. Like, why? I guess my thing is like, why does any of this work? No clean up your bit manipulation solution. Great explanations. Could someone explain what's happening? I think approach 1 is related because multiplying the previous num by 2 is the same as shifting the previous num to the left by 1. It's very interesting stuff. This is like, this is the cream of the crop, right? Where the best, this is like where you learn the most on these discussions. So I definitely need to make a note to read these, and it's good that we put it in our to revisit because we'll probably do that on the weekend. All right, let's get to our next one. Convert binary number, minimum number of moves to seat everyone. Well, anytime I see like one of these minimum ones, I get a little bit nervous. But let's see, I thought there was a question yesterday that was particularly difficult, and I was able to solve it, or maybe 2 days ago. But anyway, there are n seats and n students in a room. You are given an array seats of length n, where seats of I is the position of the ith seat. You're also given the array students of length n, where students j is the position. And perform the following move any number of times. Increase or decrease the position of the ith student by 1, minimum amount of moves. The first student is moved from position 2 to position 1. Okay. Wait, let's see what it says here, because I feel like having these. So 3, 1, 5, 2, 7, 4. Let me share these links with the people in chat in case you guys want to watch or tag along with me. Okay, so the first students, this is like my input. I'll just leave that there for reference. But it says the students are moved as follows. The first student is moved from position 2 to position 1 using 1 move. Okay. So does that mean, oh wait, that's the seats. First student is moved from position 2 to position 1. Okay. The second student is moved from position 7 to position 5. Third student is moved from position 4 to position 3. Position 2 to position 1 to position 5 to position 3. Okay, I see. First student moved from position 2 to position 1. Position 7 to position 5, and 4 to 3. Yeah, I think just like based on what I see here, well, let's see, 4, 1, 5, 9, 1, 3, 2, 6. First student is not moved. Second student is moved from position 3 to position 4. Third student is moved from position 2 to position 5. I think what we want to do is minimize the amount of space between each one. But let's like think about why that works. Increase or decrease the position of the I student by 1, moving the I student from position X. Those 2 students are in the same seat. Seat everyone. Seats 3, 1, 5. And this is, there are n seats and n students in a room. You're given an array of seats of length n. Is the position of the ith seat. So I mean, let me actually, 1, 2, 3, 4, 5. Imagine these are seats. So we have one at S, we have one at 1, and we have one at 5. And then we have students, and I'm gonna add two more here, like 5, 6, 7. These are seats, or I'll put C for chair, maybe. And then for seats, 1, 2, 3, 4, 5, 6, 7. We have 2, 7, 4. 2, 3, 4, 5, 6, 7. And when I do that, 1, 2, like how many? Oh, interesting, because there's actually there's like a couple of different ways that you can do this. And me drawing it out right now actually makes a lot of sense. Because one thing you could do, like if you realize the output, and this is just from you drawing it out, you notice that once they're all seated, like this person's gonna go to 3, this person's gonna go to 2, this person's gonna go. So we essentially just want to find the closest thing to each one of them. I mean, it'd be nice if I have both of these sorted. Actually, imagine these are already sorted, right? If I sort this and this one, and then just see the distance. Yeah, and then this the distance between each one, right? So let's do, yeah, exactly. Because imagine the chairs are sorted, the seats are sorted. Now we just want to find the distance between the seat and the chair, and we add all those up, and that should give us the answer. So let's go ahead and work on that. So let's do const sorted seats is a copy of seats because we don't want to change it. Sort A, B, A minus B. Let me lower this a little bit here. Then we have const sorted students equals students dot sort A, B, A minus B. And let's say min moves equals 0. And we can just say for let I equals 0, I less than sorted seats dot length, I plus plus. We can say min moves plus or equal the absolute value of sorted seats at 1 minus sorted students at I, not 1, sorry. And I think this should give us, the right answer here. Return moves, min moves. 4 and 4. See the different test cases that we have. 4, 7, 4, 4, 7, 4. Okay, 59, 59. So I think drawing this out was really, really nice, right? Because we see we have our sorted chairs and our sorted seats, and the answer just becomes if I want to move these people, like I'm not going to move them to a chair that's further, I'm going to move them to their closest chair. So now it becomes the distance between this seat and its closest chair, this seat and its closest chair, this seat's closest chair. Add all those together, and then we get to our final min moves. So the time complexity of this, so in job like in Chrome V8 engine, what JavaScript uses, at least in Chromium-based browsers, we know that sorting takes O n log n. So it's sort of like 2 n log n. We drop the constant, that's just n log n plus, let's see, seats and students are the same, so it's n log n plus n because of this loop. The bigger one wins, so then we get a time complexity of n log n. And I see like here, I guess the space would be O of n, where n is equal to seats and students, because I think these are both the same size, right? So O of n for space complexity, since we are creating two new arrays. So let's see what discussions have to say. There might be a faster way of doing this. C++ simple at clean solution. Yeah, sort both arrays, then greedily we loop through them and match each student with the closest seat. Nice. That makes a lot of sense. So I'm happy with this. All right, so we've done pretty good here. We've done 1, 2, 3, 4 questions. Let's get to the next one here. Oh, this one's nice. Yeah, this might, let's see how far we can get here. Count number of pairs with absolute difference k. So given an integer array nums and an integer k, return the number of pairs where I is less than j such that the absolute value of nums at I minus nums at j equals k. So this is going to be fun. We have an array of nums here, and there's, I guess, 4 different sets of numbers that their absolute difference is 0. So we have 1 and 2. Yeah, this one I haven't been able to solve before, so it'd be cool if I do it now. So 1, 2, 2, 1, we're looking for k equals 1. So, like, if I find, these all have to be unique, right? Because if I can, let's say I add 1 to 1, and that's 2. Okay, there's a 2 here. But what if I've used, well, let's get like a map going. We have a 1 at 0, we have a 2 at 1, we have a 2, let's say at 0. We have a 2 at 1 and 2, and then we have a 1 at 0 and 3. So when I'm at 1, I say, okay, do I have a 1 plus 1? Yes, I do have something available here. Okay, cool. So let me sort of like pop that off. Maybe we can do that. Pop this off. Now we're left with 2, and let's say our matches equals 1. And now we say, do I have a 1 minus a 1? Do I have a 0? No, I don't, because there is no key here of 0. So we get to the next one. Do I have a 2 plus 1? I don't. Do I have a 2 minus 1? I do. So let me remove this. Matches now becomes 2. We go to our next one. Do I have a 2 plus 1? 3? No. Do I have a 2 minus 1? I do have another one. Oh, and then we just get here, and that's 4. Here, I have a 1 at 0 and a 3 at 1. Do I have a 1 plus 3 or a 3 minus 3? I don't have anything. Let's do this one that's a little more complex. 3, 2, 1, 5, 4. 3, 2, 1, 5, 4. And k equals 2. So let's do again, matches 0. And I kind of like this idea of having this hash table which maps numbers to their indices. But I would also like to make that a little bit faster because it seems problematic. So probably better data structure for that. So we have a 3 at 0. We have a 2 at 1. We have a 1 at 2. We have a 2. Actually, I don't care about their indices, right? I just care about their count. I have 1, 3, I have 1, 2, I have 1, 1. I have 1, 5, and I have 1, 4. Okay, so 2. I say, do I have a 3 plus 2? Yes, that's 5. So let's remove 5 and increase matches. Do I have a 3 minus 2? Yes, that is a 1. So increase my match. 2. Do I have a 2 plus 2? Yeah, that's 4. So increase my match. 3. Do I have a 2 minus, do I have a 2 minus 2, 0? No. Do I have a 1 plus 2? I do have a 3, but I guess the 3 was already counted. So we have to remove the pair. And I also has to be less than j, so maybe a couple, that's like one way we can try it out. This has 200, so maybe this also seems interesting, like this could be helpful. But let's see. So maybe now we also have to remove the pairs as we're matching them. Okay, like I say, okay, do I have a 3 plus 2? Yes, I have a 3 and a 5. Remove both. That's like a pair. Do I have a 3 minus 2? That's a 1. But do I, let's see, a 3 plus 2 is 5. Well, I don't have a 3 and a 1. So maybe my logic just doesn't pick these. Now we get to 2. Do I have a 2 plus 2? Yep. Then I'm only left with 2. Because then I won't have a 1 plus 2. But you know what? Oh, I needs to be less than j, right? I is less than j. Do I have a 3 plus 2? Yes. I do have a 3 plus 2, and I is less than j, so I can remove this pair, my 3 and 5. One match. Do I have a 2 plus 2? Yes, that's a 4. But then again, we get to 1 here. 3 and a 1. We also have a 3 and a 5. Or if we go back to the original logic where we don't get rid of the one that we're starting on, like do I have a 3 plus a 2? That's a 5. Yes. I can remove the 5. That's 1. Do I have a 3 minus 2? Yeah, that's 1, and it's also ahead. Remove the 1. Okay. Do I have a 2 plus 2? Yeah, that's a 4, and it's ahead. So remove the 4. Do I have a 2 minus 2? No, I don't. Do I have a 1 plus 2? I do, but 3 is behind, so forget it. Do I have a 1 minus 2? No. Do I have a 5 plus 2? No. A 5 minus 2, but it's behind. Forget it. A 4 plus 2, and then a 4 minus 2. Okay, so a couple of interesting things here. I like this question a lot. Let me, I'm sorry, can you put the light on? All right, this is a nice question. I had to get the light on in my room. All right, so this one's good. I like this one a lot. Now I feel like I'm happy that I'm able to like reason about it better now. So I think it would be helpful. I should create a map of number to index. I think that's like the first thing we should do. So let's create that. Let's say num to index equals new map. For let I equals 0, I less than nums dot length I plus plus. Num to index dot set current thing at nums at I and the index I. Okay. So when I'm at 3 and I go to look for the 5, I'll be able to get its index. So now let's say let matches equals 0. Let me look up MDN maps again to see their API, just to remind myself of what do I need to use when I delete it. Is it just delete key? Okay, so delete key. So now we can say for let I equals 0, I less than nums dot length, I plus plus, const num equals nums at I. Now we want to add, well, we just want to add both as long as I is less than j, right? So let's see. How can we, like I know how to do it. I'm just trying to think of like a nice way to write it in code. I want to first get the addition. So let's say k positive equals num plus k if, so we first want to check if num to index dot has k positive and num to index dot has k positive, or num to index dot get k positive is greater than I. Let me move this a little bit here. If num to index has k positive, so here it has 5, and then 5's index is greater than my current I, then we can say matches plus plus and num to index dot delete k positive. And then we can say const k negative equals num minus k if num to index dot has k negative and the same thing here, num to index dot get k negative is greater than I. Then we can say matches plus plus and delete k negative. I'll look into refactoring this once I'm done, but let's very curious to see what this will give us. 2 and 4. Okay, so we don't have the answer yet, but let's see what we can do here. So num to index, we have key values, so num to index, num set I, 3 is 0, 2. Okay, so I believe that works there. Now what do? We get to I0, I less than nums at length. Num, okay, so the first num is nums at I, which is 3. K positive is num plus k, so num plus 2 is 5. If num to index has k positive, which is 5, and num to index dot get the thing at 5, which should be 0, 1, 2, 3, which is greater than 0, we can increase the matches and then delete k positive. Now we say k negative is 3 minus 2 if num.index has 1 and num to index dot get 1 is greater than I, which it is, matches plus plus. Num to index delete k negative. Okay, and we come to the next one. 2. K positive. Num plus k. 2 plus 2, 4. Okay. So for me, I feel like that should have already worked. If nums dot has k positive, which is 4, and num to index dot get k positive is greater than I, matches plus plus, delete k positive. And we came out with 3? Oh, 1, 2, 2, 1, 2, and 4. Oh, of course. I'm not also considering duplicates. So it only works if all the numbers are unique. We need to consider what happens when there are duplicates. So let's see what we can do here. It's like an efficient way for me to store these duplicates. Maybe, I wonder if I can store like, maybe I can use like a separate hash table. We can have something like, let's see, 1, 2, 2, 1. So we have a 1, and we have a 2. Is there a way, can this key be used as a key for another table? Or, I mean, we can also just have, what if we had a, does it really matter the order in which I put them in? As long as there does exist a 2 that is after, I guess that doesn't really matter, right? I always want to see, I always want to get like the closest one first, I guess. Maybe I just also want the furthest one. Like if I get to this 2, I'll say, okay, there's one at 1 and there's one at 2. So, oh, even still. So I'll say 1 plus 1 is 2. I have one at 1 and one and 2. That's fine. I get to this 1. 1 plus 2. I still have 2 left. So maybe we don't even need, I think we just need, yeah, I feel like a count, not so much the count, right? I definitely need the indices of where they last were. Maybe this is what can help here. Nums out length is 200. Nums at I Yeah, right now I'm just trying to figure out. I feel like I have an idea, but it's more of me just trying to figure out how to store it. What would be the best storage? I don't want to have to do a lookup. If I had if I had something like this, right, where I had one and two, for example, and I get to this one, right, I could say, oh yeah, I do have a 1 plus 1. Oh, but I needs to be less than j. So one plus one is two. That's fine. One minus zero, no. 2 plus 1, no. 2 minus 1. Okay, I do. Yep. And then I get two. 1 plus 1. 2 plus 1 is three. 2 minus 1 is one. I is less than j. Oh, wait a second. Integer k with the number of pairs ij. I is less than j. Wait, does the index matter? No, it's not the index, right? It's just the actual value. 1 plus 1 is 2. That could be my I less than j, and that equals 2. 1, 3, 2. The pairs with an absolute difference of 2. Do we really care about even I is less than j? Maybe I just need the ones that are of absolute difference. Do I have any numbers that will give me that absolute difference? Do I care about the index? Maybe not. Like, well, I mean, there's only one way to find out, right? Maybe instead of setting the index here, maybe we can just say, let's see, num to index set. So we can say if num to index dot has nums at I. I'm going to make this an object literal just to keep the syntax a little bit nicer. And here we can say num to index at nums of I equals nums to index at nums to index at nums of I plus 1 or 1. Let's try something new here. So now we'll say const num equals nums at I, k positive equals nums plus k. Maybe this doesn't matter anymore. Maybe we can just say if num to index of k positive not equal to undefined and num to index. Do I even need to check for undefined? I know I'm setting them here, right? So maybe we just need if num to index k positive is greater than 0, then maybe we just do matches plus plus and num to index k positive minus minus. Here, k negative, copy this. If num to index k negative, and then we'll say num to index k negative minus minus. K negative minus minus, return matches. Let's give this a shot and see. Because do I even 4 and 4? I'm not gonna lie, I'm a little bit excited, but let's see. Never know. With LeetCode, there's always an edge case, right? 405 and 403. Okay, so missing this last one here. Am I counting more than I need to? 3 plus 2 is 5. Okay, that has, and 3 plus 1 has, 3 and 5 and 3 plus 1. and then 2 of 4, 3, 1, 3, 5, 2, 4. It's also, this is also taking into account index. 1, 2, 1, 2, 2, 1, 2, 1. Yeah. So this is a mixture. This is a mixture of available, like available nums left. Like 2 minus 1 is 1, and that's greater. And the next one, oh, maybe I don't even ever need to delete it. How do I know that there's one that exists ahead of me? Oh, maybe 1 and 2. 1 plus 1 is 2. The last one is this one. Oh, we do it twice. That one's interesting. We do that one twice. Been going up for an hour and 6 minutes here. I'll give this like another 5 minutes. And if not, we will wrap it up and get back to it tomorrow here. Because now that I'm seeing this, it's not like the 2 is ahead. So should I just always look for all of them? Like, okay, I'm here. 1 plus 1 is 2. How many 2's do I got ahead that I can add? Cool, right? I can add that one. I can add that one. Cool. I get to 2. 2 plus 1 is 3. 2 minus 1. How many 1's ahead of me can I add? That's 1. 2 plus 1 is 3. Maybe anytime hmm. It'd be really nice to have a way of just getting getting where the first one starts and how many I have after this one. Is there a way to even do that? Like how many twos after this one? How many? Yeah. It might not even be that bad though. Maybe the index thing is really what I need. Because I can do 1 plus 1 is 2. I get to that 2. 1 minus 1, no. 2 plus 1 is no. And I can get to 2 minus 1. There is 1 ahead. 2 plus 1, no. There's 2 minus 1. Okay, there's 1 ahead. 2 plus 1 is 2, no. Yeah, that's the piece that messes me up. 1 plus 1 is 2, there's 1 ahead. Okay, 2. 2 plus 1, 2 minus 1, there's 1 ahead. 2 minus 1, there's 1 ahead. 1 plus 2, I get to the end, there's nothing ahead, so I'm never going to count that one. So I can't just go one by one. I always need to know at the moment that I calculate. I say 1 plus 1 is 2, and there's two 2's that are ahead of me. Can I look at the minimum? Does the minimum? What if I had, what if we go back to this, right? We have a 1 that's at 0 and 3, and then we have a 2 that's at 1 and 2. I always know that oh, wait a second. Okay, so I get to a 1. I get to a 1, right? And I say I'm going to add my case, so 1 plus 1 is 2. So now I need to find in 2, right? I go to 2 and I ask myself, is the lowest one greater than if like the lowest index here is greater than where I'm currently at, I can just add all these, right? So that's automatically 2. Then I get to 2, I do 2 plus 1 is 0. Oh, I think I like this a lot. Yeah, 2 plus 1 is 1, or 2 plus 1 is 3. There's no 3's. 2 minus 1 is 1. I say I'm at 1. Does 1 exist within this range? Oh, so it can either be out of the range. Maybe I should just always look at the top one. If it exists, oh, but what's at what range do I stop? I can't always just add. I can't always add the length of the array. Yeah, I can't always add the length of the array. We're gonna have to revisit this one. This might be one that we revisit on a weekend, or we'll just kick it off. Maybe I'll work on it on my own, and then tomorrow I'll tell you guys like what I learned. Let's see what the next one is just for fun. Check if two string arrays are equivalent. Haven't done this one before, but I think I'm really happy with how we ended things off today. This one seems really good. I feel like we made some progress. There's still a couple of edge cases I need to get here. I think the way that I'm looking at this is it's either going to be has to do something of like storing the indices of all these numbers, being able to check if they come after, if like the one I'm looking for, the different one comes after where I currently am, but then I also have to count for duplicates. So we will hopefully get to that tomorrow. So just as a quick wrap up, I upload all these streams to my YouTube channel. I've had some new subscribers over the past couple of days, so I'm really happy about that. And one thing I did today was I started adding different chapters to all these different videos. So for all the different streams I have, like for example, we can look at the one from yesterday, you'll see that it shows chapters and then also all the links to all the different LeetCode questions. So pretty cool, something like fun to look at. Highly recommend you do this. The way to do this is you either, you look at this first, solve the questions alongside me, or you do all the questions first and then watch the video to be able to practice. So stay tuned for more videos. I left the link of the YouTube channel on the stream chat if you want to check it out. Happy coding, everyone, and I will see you all tomorrow for another stream. Take it easy.